Good afternoon, beta. Am I audible to everyone? Am I audible, beta? Sure. So our last class was up to the photoelectric effect. Now let us try to do the next part of this one, beta. See this one. Most expected graph questions in the photo dual nature of matter. First question, देखो beta. Which of the following, which of the following figure, which of the following figure represents the variation of particle momentum and the associated de Broglie wavelength Okay, see the graph. Direct question है. Which of the following figure represents the variation of the particles momentum and associated de Broglie wavelength? यहाँ पर momentum है, यहाँ पर भी momentum है, यहाँ पर भी momentum है और यहाँ पर भी momentum. X axis पे अपने पास wavelength है. This is given as of your lambda, and the graph is given for me. The first graph is something like this. The second graph is like this. The third graph is like this, and fourth graph is like this. चलिए बताइए कौन सा होगा? Which of the following figure represents the variation of the particles momentum? Momentum और de Broglie wavelength का ग्राफ होना है. डायरेक्ट क्वेश्चन है, सिंपल क्वेश्चन. कौन सा ऑप्शन लिखोगे? कौन सा ऑप्शन लिखोगे? Give me the answer in the chat box. Graph of the momentum versus de Broglie wavelength. De Broglie wavelength का फॉर्मूला लिखो. Lambda is equals to h divided by p ना बेटा. P is what? Momentum only ना. So can I say that wavelength is inversely proportional to the momentum? So अगर wavelength is inversely proportional to momentum हो गया तो what will be the graph बेटा? Fourth option. Very good Sudra. Rectangular hyperbola है कि hyperbolic nature होगा? Rectangular hyperbola. Or I can say this one is hyperbolic in nature. Hyperbolic in nature. तो कौन सा ग्राफ करोगे? फोर्थ वन. वेरी गुड, वेरी गुड. चलो नेक्स्ट क्वेश्चन. वेरी फेमस ग्राफिकल क्वेश्चन है जो आपको बाय डिफॉल्ट याद रखना है. नेक्स्ट वन. इन द फॉलोइंग diagram, if V2 is greater than V1, then first option is lambda 1 is equals to under root of lambda 2. Second option is lambda 1 lesser than lambda 2. Third one is lambda 1 is equals to lambda 2. Fourth one, lambda 1 is greater than lambda 2. This is a graph given for me. ठीक है. चलिए, दिस इज वन स्टैंडर्ड लाइन है. इसके बाद यहाँ पर से ऐसा ग्राफ आ रहा है, देन फिर ऐसे हो लेते हुए फिर ऐसा. और ये हो गया पोटेंशियल V1 और ये हो गया पोटेंशियल V2। एक्स एक्सिस पे देयर विल बी योर पोटेंशियल कैपिटल V और वाई एक्सिस पे होगा फोटो इलेक्ट्रिक करंट, फोटो इलेक्ट्रिक करंट रिप्रेजेंटेड बाय आई। ठीक है, और इसका डी ब्रोगली वेवलेंथ यहाँ पर लैम्डा 1 और यहाँ पर हो गया लैम्डा। कोई आंसर बता सकता है? इन द फॉलोइंग डायग्राम इफ V2 इज ग्रेटर देन V1 यानी ये वाला पोटेंशियल ये वाले से ज्यादा है, देन व्हाट इज द ग्राफ? व्हाट इज द ग्राफ? एनीवन गिव मी द आंसर बेटा। एक जने थर्ड ऑप्शन बोल रहे हैं, एक जने फोर्थ ऑप्शन बोल रहे हैं। सुग्रा इज टेलिंग फोर्थ ऑप्शन, फोकस वाले थर्ड ऑप्शन। और कुछ कंडीशन बताइए बेटा। व्हाट इज द रिलेशन बिटवीन द पोटेंशियल एंड एज वेल एज ऑफ योर करंट? फोटो इलेक्ट्रिक इफेक्ट के लिए कंडीशन आपको मालूम है, स्टॉपिंग पोटेंशियल जो हो रहा होता है ना, दैट शुड बी डायरेक्टली प्रोपोर्शनल टू योर फ्रीक्वेंसी, isn't it? Stopping potential जो होता है right now for me, that is nothing but potential V naught is directly proportional to frequency. mu क्या है यहाँ पर? Frequency. And V naught क्या है यहाँ पर? Potential. This is your stopping potential. We know the relation. Potential is directly proportional to the frequency. And how the wavelength is related? Wavelength is inversely proportional to your mu, isn't it? Am I clear? Am I clear? So V2 is greater than V1. So I can say that mu2 will be greater than mu1. Isn't it? So I can say that lambda 1 will be greater than lambda. Lambda 1 will be greater than lambda 2. So what is the option I can write right now here? Fourth option. Very good. Am I clear? Am I clear? Okay. Don't give me the answer for this question. The anode potential, or I can say anode voltage of a photocell is kept fixed. Is kept fixed. The wavelength lambda of the light falling on the cathode is gradually changed. From March 19th or 20 beta, we'll be again starting from the basics, complete modern physics, wave optics, and heat and thermodynamics, KTG, units and dimensions, screw gauge, vernier calipers, scoring topic to do at least 20 questions in the final. And for next 40-45 days, we'll try to extensively revise only these chapters. And जिनका अभी तक physics almost like zero है, you can accelerate it at least to do 20 questions. Believe me, if you follow my lectures and try to do the assignments which I'm giving you, you can easily crack and do like 20 questions in your final part. And that will be doing seriously from your this month of your 18th or maybe 20th. Okay, and I'll be doing only the scoring topics. I'll not waste your much of time keep doing unnecessary things and making you make sure that you're not able to do. I'll try to do again modern physics once again in detail with the theory, with the shortcuts, with the formulas, again new problems, new concepts, and type of revisions with that one. And also the second year may wave optics will do in detail, current electricity will try to do it in detail, and we will try to do KTG, thermodynamics, scoring topics, units and dimensions. Repeatedly we'll try to do, and I'll try to say that we'll try to do 20 grand tests exclusively on physics, and every grand test we'll try to pick up only that 20 questions, and we'll try to make a practice of doing only that 20 questions from every grand test rather than doing complete paper. We'll first read the complete paper and we'll try to sort out the questions which have been learned only from every model paper. We'll try to do only that what we call that one grand test papers From every grand test papers, we will try to see that 20 expected questions only we will try to solve. Like that, we will be doing 20 papers so that you will get an adequate practice that how to choose the questions out of the 50. Am I clear? Sure. All those whose physics is zero, you can start also right now better. You can start right now with me. You can easily accelerate 8 to 20 questions very easily because I'm already trying to do only those chapters which are purely connected to the chemistry also. So it will help you out with the chemistry and it will also give you the score in the physics. Got it? I'll tell you the chapters better. I'll tell you the chapters in detail. What are the scoring chapters? How many times we'll be doing, and how many grand tests we'll be doing. And every grand test we'll try to do only the 20 questions of your practice. My grand test I'm telling you. I'm not talking about your college grand test. Your college grand test will be different. My grand test will be purely on the physics part only. And in every grand test papers, I'll try to make you to first learn how to select the questions of modern physics. What are the questions you can select, and we'll try to see that only we'll try to do the selected questions every time. So that our score you will skip our score will try to jump from 80 to 120 every time in every grand test. Okay. So see this question. Diode voltage of a photocell is kept fixed. The wavelength lambda of the light falling on the cathode is gradually changed. The question is the plate current of the photocell varies as very famous graphic. You might have been already studied it. I'll just draw the graphs roughly. 1, 2, 3, and 4. Okay. So this is your current versus your lambda. Current versus your lambda. Current versus your lambda. Current versus your lambda. Okay. The graph in this ones are given like this. This is the one graph, and this is your another graph. This is your another graph. This is your another. Anyone? The anode voltage of the photocell is kept fixed. The wavelength of the light falling on the cathode is gradually changing. The plate current of the photocell varies as follows. In photoelectric effect, we know that on increasing wavelength, what happened to the photoelectric current? Increases. Incident current, na beta. So photoelectric current also increases or decreases. Tell me. On increasing the wavelength, what happens to the photoelectric current? Very good. Photoelectric current decreases, not increases. Because E is equals to HC divided by lambda. Isn't it? If wavelength is increased, energy will be decreasing. If energy is decreasing, the number of photoelectrons coming out will also decrease. Which chapters are? This is dual natures. Okay. On increasing the wavelength, photoelectric current decreases. Okay. And at a particular wavelength, like say lambda is equals to lambda naught, the current I becomes 0. Listen, now tell me what is the graph you can take? As you are increasing the wavelength, see from here if I am starting, as the wavelength increases, current decreases and finally becomes 0. यहाँ पर wavelength increases becomes 0, decreases. यहाँ पर as wavelength is increasing, current is also increasing. This is not possible. So only the best option I can choose right now for this one is what beta? First option. Very good. Am I clear? Am I clear? Okay. Next question. A general question. The photoelectric cutoff voltage in a certain experiment in a certain experiment is 1.5 volt. Okay. What is the maximum kinetic energy? What is the maximum kinetic energy of photoelectrons emitted? Direct question है बोलना. Should tell this answer better. The photoelectric cutoff voltage in a certain experiment is given as 1.5. Okay, that means he has given me the potential. Is asking the maximum kinetic energy. What is the formula? Can anyone tell me what is the formula for K max? Maximum kinetic energy will be equal to charge into potential, isn't it? So what is the charge? 1.6 into 10 power minus 19. Potential is how much for me? 1.5. Isn't it? So 1.6 into 1.5. कितना हो रहा है देखो? See this one. 1.10 power 19. This value, see how much I'm getting. That will be the answer. Anyone? Two point four. Very good. 2.4 into 10 power minus 19. Am I clear? Done? Sure. Very good. Next question देखो. The work function, pen paper लेके करो जल्दी से. The work function for a certain metal is 4.2 electron volt. The question is, will this metal give photoelectric emission? Will give photoelectric emission for incident radiation of wavelength 330 mm. 330 mm. So try to do it. Take a minute of your time. Aya, 1 minute is over. Work function for a metal is how much for me? 4.2. Work function is given as 4.2 electron volt, or wavelength of the light which is been incident, lambda is equals to 330 mm. This is given data. Karna kya? What is asking? Work function is given. Will this metal will give photoelectric emission? Now we know that photoelectric current is been emitted if your work function is greater than of your incident energy. होगा क्या? अगर आपका incident energy is greater than work function, then only photoelectric effect will take place. Isn't it? If energy is lesser than work function, photoelectric effect will not take place. That's it. See this one. Okay. So for a photoelectric effect, I can write for photoelectric effect, whatever you are taking the energy must be greater than work function. E here E is your incident for radiation of energy. That energy is equal to how much for that one? Wavelength is given, na beta? In mm it is given. So I can write the energy E is equals to HC divided by lambda. That value of H is 4.14 into 10 power minus 15 multiplied by 3 into 10 to the power of 8 divided by wavelength 3 into 330 into 10 power millimeter 10 power 9. See how much I am getting this. See how much I am getting. आई होप यू रिमेंबर द वैल्यूज ना बेटा। h की वैल्यू एक्चुअली कितनी होती है 6.6 इंटू 10 पावर माइनस 34। डोंट गेट कंफ्यूज, जॉर्ज सेकेंड। h is equals to 4.13 or 14 into 10 power of your minus 15 electron volt second. Okay, energy unit is in terms of electron volt. Now that is the reason I'm taking the value of h as 4.14 into 10 power minus 15. So simplify this one, see how much I'm getting right now there. 4.14 into 3 is 12.42 divided by this one is 330. This is 10 power minus 15 into 10 power 8 into 10 power plus 9. This is coming out for me 0.037 into 10 power minus 15 into 10 power. This is 17. Done? Got it? So our energy is 4.2. This is approximately अगर मैं सोच रहा हूँ this will be somewhere around 3.7 के पास आ जाएगा into 10 power minus n electron volt. So obviously your energy is lesser than of your work function. As your energy is lesser than work function, so there is no photoelectric emission. So the answer is no photoelectric emission. Answer. Got an idea how to identify that one? पूरा photoelectric equation लिख के मत करिए, work function दे रखा है and if is asking whether it will emit a photoelectric or not, then directly आप energy निकालिए, but make sure that energy का formula जब आप लिखोगे hc divided by lambda, make sure that value of h जो लेना आप electron volt में लेना, तो not in this value. So this value is this one. ये value याद रख लीजिए. Clear? Clear बेटा? फोटो इलेक्ट्रिक इफेक्ट में जितने शॉर्टकट्स होते थे उतने मैंने बता दिया। थोड़ा ग्राफ्स पे आपको कंसंट्रेशन करना है और थोड़े पीवाईक्यूज ऑफ योर वेरियस इसके कर लो बेसिकली। आप लोग का फोटो इलेक्ट्रिक इफेक्ट हो गया बेटा? ड्यूअल नेचर आई थिंक वी हैव डन सम क्वेश्चंस। इसको एक बार आप लोग प्रैक्टिस कर लीजिए बेटा। ड्यूअल नेचर इज 15 क्वेश्चंस, आई हैव डन इट। there are 25 questions on this one. दिस मॉडल्स एक बार आप कंप्लीफाई कर लीजिए, क्या आपके पास है ना? इसको आप लोग खत्म कर लीजिए एज अर्ली एज पॉसिबल। तो ड्वेल नेचर आप लोग खत्म कर लीजिए, कीप ए फुल स्टॉप फॉर द ड्वेल नेचर। पीवाईक्यूज भी खत्म कर लीजिए एक बार, एंड ये असाइनमेंट के जो 15 क्वेश्चंस दिए थे मैंने, इसको भी एक बार आप खत्म करिए। Your role is only to complete well nature as early as possible. ठीक है, इससे पहले मॉडर्न फिजिक्स के मैंने 25 क्वेश्चंस किए थे, और 25 क्वेश्चंस ए वाले क्वेश्चंस और पीवाईक्यू बस काफी है, एक से दो क्वेश्चंस पढ़ते हैं इसके अंदर, विल ट्राई टू वर्क आउट ऑन दैट वन। ठीक है ना, हम लोग मार्च 15 से जो क्वेश्चंस करने वाले हैं, देखो बेटा जो चैप्टर्स करने वाले हैं, पहले वाला तो अपन विल ट्राई टू डू कंप्लीट मॉडर्न फिजिक्स। ठीक है, मॉडर्न फिजिक्स मतलब इन दिस वन विल ट्राई टू डू ड्वेल नेचर, then we'll try to do atoms, then we'll try to do nuclear physics, then we'll try to do semiconductors and devices. Okay, इसके अंदर दो क्वेश्चंस, इसके अंदर एक एटम्स में से भी एक, ड्वेल नेचर भी एक, इसमें से कभी कभी चार भी हो जाते हैं बेटा, यानी टोटल राइट नाउ दिस आर 5 क्वेश्चंस, इट मींस 5 into 4 20 मार्क्स। इसको आप मिनिमम 10 डेज करना रिपीटेडली, 10 डेज डेली 4 आवर्स का टाइम फिजिक्स के लिए rigorously वर्क करोगे, then it will work out. Next one is we'll try to do current electricity, जिसमें से अपने को 2 या 3 क्वेश्चंस निकलते हैं। ठीक है ना, तो मान के चलो इसमें से अपने को 8 मार्क्स का कंडीशन, दिस विल ट्राई टू डू फॉर एटलीस्ट 3 डेज, डेली आपको 4 आवर्स का टाइम देना है। ठीक है, देन विल ट्राई टू डू वेव ऑप्टिक्स, इसमें से भी 2 क्वेश्चंस निकलते हैं, यानी इसका भी 8 मार्क्स वेटेज, इसको भी 3 डेज देना डिटेल में, डेली 4 आवर्स के कंडीशन, वजह के साथ बैठो जैसा आपकी मर्जी, वॉट एवर टाइमिंग फिट। देन इन फर्स्ट ईयर विल ट्राई टू डू विद ग्रेविटेशन, this one is damn sure 1 question and easy question, so that is your 4 marks. Sometimes we even get 2 questions, but I'm taking the least possibility. Then KTG, and this one is also one question, and this one is also 4 marks. Okay, then after this we'll try to do units and dimensions plus errors plus instruments. This will be having approximately 3 questions. So it is 3 into 4. That is equals to 12 marks. Okay. The next one is, after this, we'll try to do with your thermodynamics. In generally, we'll get 2 questions from this. That is 8 marks. Okay. Gravitation also should give 2 days with daily 5 hours of time. This also 2 days, daily 3 hours of time, like morning 1.5 hours and next 2-3 hours on your own. Units and dimensions, you should give 5 days and daily again 5 hours. Okay. The thermodynamics also right now, let's say like 2 days, and daily is right now for me 5 hours. Okay. The next one is thermal properties. Thermal properties of solids. That is elasticity. Damn sure one question. Small chapter. Elasticity, one question. That is equals to 4 marks. This you should give again 2 days. Daily 5 hours. Okay, and don't take it like a small chapter. We need to do everything with the scratch and need to become perfect in that one. Done. Then 9th one is from the first year topics. You can do any other chapter which you feel comfortable. But if I take the scoring of this one right now, so this one is how much for me? 4 marks. Then we have got 8 marks. Then 12 marks. Then 4 marks. Then plus 4. Then how much I got? 8 marks. Then again 8 marks. Then 20 marks. So if you do this one, this is approximately coming out for me 68 marks. Okay. Now there are some other chapters which you can do, like in first year and second year. Like say you can do some small chapters, which we can do it later part. But these are the chapters which we need to do rigorously and make sure that we try to do any type of questions in the final examination. Elasticity or thermodynamics or units and dimension, KTG and current electricity. I have not written the electricity part. I have not given you right now like electrostatics, electric field, Coulomb's law, but all I have not taken. That we'll try to do in the second phase, but provided in the first phase, we'll try to complete your modern physics detailing, then we'll try to do current electricity, then we'll try to do with wave optics, then we'll try to go with gravitation, then KTG, then units and dimensions and errors and instruments करेंगे, then thermodynamics. इतना rigorous करेंगे that we'll try to do daily right now, like say इसके ऊपर मैं आपको literally 50 questions करवाऊंगा हर चैप्टर में से, इसके अंदर भी उतना ही बेसिकली. इसके साथ आप PYQs कर लेना और इसी क्वेश्चंस को प्रैक्टिस कर लेना और थियरी भी पूरा मैं ही करवा दूंगा. I'll do the complete theory related to this one on my side and you need to do on your own remaining workout. But you need to give this much amount of time daily and try to refer my class notes and daily try to do the assignments or the questions which I am giving you to do. Okay, and these classes are not going to be online. These are purely personally based and everyone should on their videos while doing the lecture because I need everyone to see that whether they are doing or not. It's not like just teaching and going. Once I complete modern physics, I'll check it out that everyone have been perfect in that one and I'll give you assignments for everyone. You should complete and submit it online then and there itself. Okay, and if you are not able to on your videos, please don't join the classes. I'm very serious related to this one, isn't it? But I need everyone to on your videos and be interactive with me and learn it. It's hardly a matter of 40-45 days. Okay, and make sure that these classes are not going to be anywhere online. It is purely between you and between me and between our interaction conditions. Clear? And remaining some other chapters, if you are perfect, you let me know. And apart from this one, what I'll be doing is I'll be doing 20 mock tests on this one. I've already prepared them. So from this 20 mock tests daily, in every mock test I'll try to do this 20 questions roughly. Okay, so 20 questions means 20 into your 4, that means 80 marks every grand test papers will try to do. Okay, like that every question we are having 20. Okay, so 20 into 20 grand test, so that will be 400 best questions we'll try to do from this one, expected, because in the short term that's only I can do because I'm not going in much detail. Highly expected 300 or 400 problems we'll try to do in this grand test. Okay beta, so now your duty is you complete your dual nature once on your own. Today or tomorrow I'll send you one assignment on dual nature, you try to complete on that. Okay, clear? आज ड्यूअल नेचर खत्म कर लो आज आप लोग को I'll try to send you the dual nature one assignment, you complete it and I'll try to discuss the complete key with the working of that one in the next session of the class. Next session होगा evening की class में. Today evening again there will be a class from 9:30 p.m. and that will be based on dual nature. Dual nature का assignment करेंगे basically जब तक आप perfect हो जाओ और आप लोग को answers देना है साथ में मेरे साथ. Clear? Clear बेटा? Take care and try to complete the dual nature today. Dual nature को खत्म करो. Bye.